Yeah, this is Module 7, Use Properties of Parallelograms. We are going to be finding angle and side measures of parallelograms. We're also going to be defining what a parallelogram is. You have to remember something from a previous module from Semester 1 about parallel lines cut by a transversal, what it means to be congruent, supplementary, and bisect. That's also a module from Semester 1 as well. So, without further ado, we have what a parallelogram is. And all a parallelogram is, it is four sides, so it's a quadrilateral, four-side polygon, with both pairs of opposite sides that are parallel. So remember the notation from Semester 1's modules, that these two arrows indicate parallel, these arrows indicate parallel. So we have, and again the notation, we have PQ is parallel to RS and QR is parallel to PS. So all this indicates is that these two sides are, both pairs of opposite sides are going to be parallel, which makes it a parallelogram. So a few theorems that are associated with this. If a quadrilateral is a parallelogram, we establish that it's a parallelogram, then we also know not only are both pairs of opposite sides parallel, but that both pairs of opposite sides are congruent as well. You have to remember the congruent notation as well. So we have double dash marks indicating these two side lengths are congruent, single dash marks indicating these two side lengths are congruent. So if we know that PQRS is a parallelogram, we can say that PQ is congruent to, remember the congruent symbol? Congruent. PQ is congruent to RS segment, and QR is congruent to PS's segment. Theorem 8.4, again, if we establish that a quadrilateral is a parallelogram, then its opposite angles are going to be congruent. So, again, you can have a few different ways of indicating congruence in angles. You have the arc marks. You can also have the dash marks within the arc marks indicating angle congruence. So if we know that angle Q and angle S are congruent and angle P and angle R are congruent, we've established it's a parallelogram. This property has to hold true as well. So opposite angles, the ones that are directly opposite each other, so these two angles here and these two angles here are going to be congruent. So, with the established theorems that we just had, here's your few examples. So if we know that ABCD is a parallelogram, that's what I tell you. So that means all of the properties that hold true, the three properties that we just went through. Opposite sides are parallel, both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, and opposite angles are congruent as well. So, in this, we're finding the value of x and y. Well, I see, let's find x first. I see that since this is a parallelogram, that x plus 4 has to equal 12, because opposite sides are congruent. So x plus 4 equals 12, and you solve, and you get x is equal to 8. Opposite angles are going to be congruent as well. So we know opposite angles are congruent. So y is going to be equal to 65. And you're finished. Those are your two angle measurements. Or two angle measurements here, and one value of x here, which gives us 12 for the opposite sides. Okay. Number 2, find FG. Again, we know it's a parallelogram based off of the labeling. We have two pairs of opposite sides that are parallel. Which means that we can establish, we say that it's a parallelogram. That means all of the properties that we know, the theorems that we know that are associated with a parallelogram are true. So, if we know we're trying to find FG's length here and the measure of angle G. So FG's length, if I look at this, FG is opposite HE. So we know HE is 8. That means FG has to be 8 as well, because it's the opposite side. We know that angle 60, angle E is 60. That means opposite angles are going to be congruent, so that means we have 60 degrees. For number 3, a little more algebraically involved, but again, the same exact thing. So we have opposite sides are congruent. Both pairs of opposite sides are congruent. So we have 18 has to be congruent or equal to y plus 3, so we have 18, equals y plus 3. Therefore, y is equal to 15 if you solve it algebraically. And again, opposite angles are going to be congruent. So we know 2x is equal to 50. Solve, you get x is equal to 25. Not 25 degrees, but 25. That will give you, when you plug it in and replace it into x, that will give you the measure of 50 degrees for your angle. Okay, so this is from the semester 1 module. What do you remember about consecutive interior angles? If you have two parallel lines, this is your transversal. If we have consecutive interior angles, remember, corresponding angles, similar position angles, are going to be congruent. So if we have corresponding angles here, y and y, then what do x and y make? Well, they're a linear pair. So linear pair adds up to 180 degrees. Therefore, consecutive angles in two parallel lines cut by a transversal are going to be supplementary. So we know x plus y has to be supplementary or adds up to 180 degrees. This is another property of a parallelogram. So if a quadrilateral is a parallelogram, its consecutive angles are going to be supplementary, which add up to 180 degrees. So that's 180 degrees. So if we know, we established that PQRS is a parallelogram, then x plus y has to equal 180 degrees. You also notice opposite angles are still congruent. Opposite angles are still congruent here. Opposite sides are still going to be congruent. Opposite sides are going to still be parallel as well. So all of the properties still hold true if you establish something as a parallelogram. Next property. If you establish a quadrilateral as a parallelogram, its diagonals are going to bisect. Bisect, that's a word from first semester module. Bisect means cuts in half. Because bi means two. So, if I draw diagonals, this is from a previous module in this chapter section. So if I draw a diagonal from Q to S and a diagonal from P to R, they're going to intersect at a point, and that point of intersection we call it M. That means it's going to cut so that QM is congruent to SM. We know that PM is going to be congruent to RM as well. So all of these properties of parallelograms you need to know, because again you're going to run into some examples with it. Okay, so part of the extending arm of a desk lamp is parallelogram. I tell you it's a parallelogram, so that means everything that we know about a parallelogram holds true. Opposite sides are congruent. Opposite sides are parallel. Opposite angles are congruent. Diagonals bisect each other. So, the angles of a parallelogram change as the lamp is raised and lowered. It's asking you to find the measure of angle BCD when we know that ADC is 110 degrees. So, what I'm going to do is I'm going to label ADC's angle. So ADC is this angle right here. That's 110 degrees. So, we're trying to find BCD, which is this angle right here. Okay? So what do I notice? Since we know that this is a parallelogram, it tells us twice, we can say that these two angles are consecutive. They're right next to each other. So if they are consecutive angles in the parallelogram from a previous theorem that we just learned, the angles are going to be supplementary. So that means you can set up and say measure of angle BCD plus the measure of angle ADC is going to be equal to 180 degrees. Use the substitution property. We know ADC is 110, so measure of angle BCD plus the measure of angle ADC, which is 110 degrees, equals 180. Subtract Get measure of angle BCD equals 70 degrees. And you're done. Because that's consecutive interior angles of a parallelogram equal 180 degrees, or are supplementary. Okay, last example. Now I have a parallelogram. It says find the indicated measures in the parallelogram. That means all of the properties that we know are true in this. So we have opposite sides of a parallelogram are congruent. Opposite sides are parallel. Opposite angles are congruent. Consecutive angles are supplementary. And diagonals bisect each other. That's 5 properties. So we are given certain things here. What you could start doing is just start labeling all the things that you know, or you could just say, okay, well, number 6. What is number 6 asking? NM. We know NM is this segment right here. Well, this segment right here, remember, diagonals bisect each other, so what's the segment that is actually bisected? That means that this is your congruent segment, because N is going to be the midpoint right here. So if we know that Kn is 2, that means Nm has to be 2 as well, because diagonals bisect each other. What about number 7? So we're trying to find Km's length. Well, we know that Nm is 2. Km's length has to be 2 plus 2, which is 4. So you're adding, you get 4. Okay, now let's talk about the angles. We have the measure of angle JML. Well, we know the measure of angle KJM is given as 110 degrees. JML is this angle over here, which we need to find. So remember, in a parallelogram, these two angles, they're called consecutive angles. That means that they're going to be supplementary. So again, we can say 180 degrees minus 110, because that's the angle that we know, equals the measure of angle JML. So that's 70 degrees. Equals the measure of angle JML. Okay. So now, if we know, it's asking, the last one, number 9, it's asking for KML's length, or angle measurement, KML, which means it's this part of the segment right here. So we're trying to find this part right here, this part of the angle. Well, we know from the previous one, from number 8, that the entire length angle measurement is 70 degrees. We know this part here is 30, so what's the missing part? You have to do 70 minus the 30 that you know equals the measure of angle KML. So, I was asked a few properties. I used diagonals bisect each other. I used consecutive interior angles, and I also used the label of the 30 degrees that splits up this angle here. And the thing that people get mixed up with, diagonals bisect each other. They don't bisect the angles. So this is not automatically 30 and 30, which is what some people believe. And that is true for a particular quadrilateral, but not for just a parallelogram.